Hi everyone, so this is our year 11 target grade 9 live stream. So I thought what I'm going to do with this one is pretty much similar to what I did last time. Is I'm going to use I'm going to go through a paper, but like from back to front, okay? And so like start with all the most difficult questions first. So this is mock set 8, which is like, I think it's from like 2023, something like that, paper 3. And we're going to start at the end and work through to the beginning. So we're going to look at all the like grade 9 questions going through to grade 8 and then towards the 7 ones. Okay, so we're starting at the back of the paper. So let's have a look and see what's at the end of this paper. Okay, now if you have any questions as I go through, just pop them in the comments and I will endeavor to answer your questions. So what's it say here? It says find algebraically the set of values of x such that x squared is less than 25 and 4 open bracket x minus 1 is greater than 3. So the first thing to do is to rearrange the way in which they've written the x squared is less than 25. Okay, so what we're going to do is take the 25 across to the other side. So that gives us x squared minus 25, which we might recognize as being the difference of two squares. Okay, so we factorize that, and that's going to factorize into x minus 5 and x add 5. Okay, so now it's always useful to represent these on a little diagram. So there's our quadratic. We've got minus 5 and plus 5, and we're looking for the solutions, the range of solutions where x is less than 0. Okay, so x is less than 0 is where we're underneath this curve here. So the set of solutions to that one is x is less than 5 but greater than minus 5. Okay, now let's look at the other inequality, this one here. So for this one, I've expanded the brackets to start off with and then taken the 3 across to the other side. So we've got to solve this quadratic. Okay, so yeah, it looks to me like we're going to need to do the old rainbow split method for factorizing this quadratic. Look, there's the rainbow and there's the split. So what do I mean by the rainbow split method? Well, you basically do 4 times minus 3 gives you minus 12. And then you say to yourself, I'm looking for two numbers that times together to make minus 12, but add together to make minus 4. And you then consider the factor pairs that it could be. Okay, so it could be, and it turns out it's minus 6 and plus 2, because minus 6 times plus 2 makes minus 12, so that works. And minus 6 add 2 makes minus 4, so that works. So then what you do is you split this middle term. So we've done the rainbow, now it's time for the split. And you split it into minus 4x into minus 6 and plus 2. And it really doesn't matter which way around you write them. Sometimes students wonder, does it matter which way around you write them? And it doesn't. But it makes sense to put the 6x here with the minus 3, just because you've got a common factor of 3 there. So therefore, I've got 4x squared plus 2x minus 6x minus 3. So you now factorize the first two by taking out a factor of 2x. So that gives us 2x open bracket 2x add 1. And you take out a factor of minus 3. And that leaves us with 2x add 1 as well. You know it's correct, by the way, if these two brackets match each other, okay, which we can see that they do. And then whatever's written in front is the other bracket, okay? So 2x minus 3 is the other bracket. So we factorize that second one now, and we're looking for the region where this is greater than 0. So we've got 2x minus 3, so that means x is 3 over 2. And 2x add 1, which means x is minus a half, okay? So it's got to be greater than 0. So we're looking for the region where x is greater than 3 over 2, or x is less than minus a half there. So those are our two regions. Now, this question is saying, where is it the case that they're both working? Now, the way to do this is to represent them both on a number line, okay? So the first one, the first inequality gave us less than 5 but greater than minus 5, whereas this inequality says it's got to be greater than 3 over 2 but less than minus a half. And you can see how straightforward it is when you represent it on a number line. We're looking for the region where both inequalities are working, which is there and there, okay? Because we've got both of the lines there and both of the lines there. So that combined region is x is less than a half and greater than -5, or x is less than 5 but greater than 3/2. And that's our combined region, okay, for those inequalities. If, as I'm going through this, you have any questions, just type them in the chat and I'll answer your questions in real time, okay? All right, next one. What have we got here? It says A, B, and C are points on the circumference of a circle with a center O, and AOB is the diameter of the circle. Prove that the angle ACB is 90 degrees, and it says you must not use any circle theorem. So you've got to prove a circle theorem without using any circle theorems. Okay, let's have a look and see what's happening. Well, I think this is a really tricky question, really, really difficult to know what the right way to answer this one is. And the breakthrough idea on this particular question is, if you imagine a line drawn from 0 to C, that's the key to this whole question. Because if you've got a line drawn there from 0 to C, then you can see that what you've got is two isosceles triangles, okay? Because you've got a radius from O to A and a radius from O to C. So that means that this is isosceles, and those two angles there are X. This triangle here, triangle COB, is also isosceles, and that angle is Y, and that angle is Y. So therefore, what we can say is, we can say that X add Y add Y has to equal 180 degrees, okay? So in other words, that means that 2x add 2y is 180 degrees. Or in other words, x add y, which is this angle here, has to equal 90, okay? And that is our proof. And we haven't used any circle theorems in that proof. All we've used is the properties of an isosceles triangle. And the reason that this works is because it doesn't matter where this triangle is drawn, this proof, this argument would always hold, no matter where you are on the circumference, okay? So the key was to draw this line OC and recognize that we had these two isosceles triangles. Write down an expression for the angle sum, divide it by 2, and that gave us that x add y is 90, which means that those two angles there are going to form a 90-degree angle. So we've proved that the angle ACB must be 90. Okay, that's that question. Not a nice one, I don't think. That was a little bit tricky. Question 20, what is going on with this one? ABC is an isosceles triangle, it says, okay? The area of the triangle is 42.5 centimeters squared. Work out the size of the angle ABC. So ABC. So ultimately, we want to know this angle down here, ABC. Okay. So to start off with, though, I'm going to basically work out what this angle is up here, which I've called X. And in order to do that, I'm going to use the fact that the area of a triangle is half AB sine C. Okay. So the area is a half times A times B times the sine of the angle in between. They tell us in the question that the area is 42.5. We know that those sides are both 11. So the only unknown is the sine of X. And from that, we can work out what the angle X is. So all I've done is times by 2 and divide by 11 times 11. And I get that sine of X is equal to this. So we do inverse sine to get the angle. Okay, so we found that that angle at the top is 44.626. Now, the question's asking us to find this angle down here, angle ABC. Notice that our triangle is isosceles because we've got that AB and AC are both the same. So in order to find out this angle down here, what I need to do now is 180, take away the angle at the top, divide it by 2. And that gives us 67.7 degrees. And again, as I say, if anyone has any questions, just if you get unsure about anything I'm saying, just put it in the chat and I'll answer your question. So that's how you do question 20. All right, let's carry on. Next one. Oh, this one's really popular. This kind of question seems to be coming up quite a bit. And in my experience, students don't know how to answer this question very well. So question 19, it says, here is a distance time graph. Calculate an estimate of the gradient of the graph at time 5 minutes. Okay. Now, it's a very particular thing that they want you to do for this. What they want you to do is draw a line. You must draw a tangent at the point. Okay. So at the time, 5 minutes, you need to draw a tangent. And there's a mark just for drawing that tangent, okay? Now, it says find an estimate of the gradient, okay? We've got a distance time graph. They could have said find the speed, because speed is also given by the gradient of a distance time graph. But they've just said find the gradient. So gradient is rise over run, or change in y over change in x. And from my graph, I got 27 was that height, and I got 7.5 was my distance along there. So that gave me a gradient of 3.6. But in the mark scheme, I think there's a range of values that they would accept, so between 3.4 and 3.6, I think it was. Oh, part B is the point that I've already alluded to. It says, describe what your answer represents, okay? Yeah, so right, now the next thing is we've got so when you've got a gradient of a speed time graph, a gradient of a distance time graph, that gives you the speed, okay? So that is the speed. Okay, perfect. Right, someone says a comment, what is a GCSE? You're from somewhere different. Okay, GCSE is General Certificate of Secondary Education. It's basically the qualification that replaced what used to be called O-levels in 1988. Okay, so right, next bit. It says, now this bit again, super important. This is a gift, considering this is like right near the end of the paper. This is worth quite a few marks, and it's really quite nice. So it says work out an estimate for the area under the graph between t equals 2 and t equals 8. And it says use 3 strips of equal width. Okay, so we've got to try and work out the area underneath the graph in this region here that I'm shading now. Okay, and the way that we do that is we've got 3 trapeziums, you can see. So this first one has a height of 4 on the graph there, you see. When we've got 2, we have a height of 4. The next one at 4, it goes up to 6 there. And at 6, it goes up to 7.2, that is. And at 8, it goes up to 8. So now we just need to work out the area of each one of those trapeziums. And you might remember that to find the area of a trapezium, we add together the 2 sides, divide it by 2, and multiply it by how far apart they are. So in the first one, we're going to have 4 add 6 divided by 2 times by 2. That gives us 10. Then the next one's going to be 6 add 7.2 divided by 2 times by the width is 2. That gives us 13.2. And the last one, 7.2 add 8 divided by 2 and times by 2 gives us 15.2. So we add those together, and that gives us our area underneath the graph, 38.4. So really nice question. I mean, how many marks is that question worth altogether? Let's have a look. 7 marks. Wow. I think that's 7 marks that's accessible, I would say, to most students, really, because all you've got to do is draw a tangent at 5 and work out the gradient. Remember that speed is what you get from the gradient of a distance time graph, and basically work out the area of 3 trapeziums. So I think that's a super nice question for quite near the end of a paper. Question 19, that was a very nice question. Now this one, oh my goodness, I know from past experience, students do not like this question at GCSE for sure. This one, as it happens, is not too bad. This one's quite a relatively nice instance of this particular question. And the topic, by the way, is called recursive iteration. So it says at the start of year N, the population of a village is Vn. Okay, at the start of year N, the population of the village is Vn. At the start of the following year, the population is given by the formula, is given by Vn add 1, where Vn add 1 equals 0.8 times Vn. At the start of 2018, the population of the village was 375. Show that the population of the village was less than 200 at the start of 2021. So we start off in 2018 with 375 people in the village, okay? So 2019 is going to be 0.8 times 2018. So you do 0.8 times 375. So therefore, at the start of 2019, there's only 300 people in the village. So 2020 will be 0.8 times 2019. So 2020 is 0.8 times 300, which is 240. And then the start of 2021 will be 0.8 times by 2020 rather, which is 0.8 times 240, which is 192. So at the start of 2021, there was 192 people in the village, which is less than 192, which is less than 200. So not a nice topic, but I think that's quite a nice question. You couldn't really expect for a nicer question on that. And it's kind of, the topic really is recursive iteration. And the idea is that you have some function, in this case 0.8 times by Vn, and what comes out is n Vn add 1. And the idea is it's like a function that's linked to itself. So it kind of like goes round and round and round in a loop. You start off with some value like V0, and then what comes out is V1. And then V1 goes in, and what comes out is V2. And then V2 goes in, and V3 comes out. So it's just like a function that's kind of like linked to itself, as it were. So that's called recursive iteration. But that was not a bad one. I've seen worse. Okay, this one again. Now, again, in my experience, students, tend not to like this question. But again, this is a really, really nice question of its type. So this is extended trigonometry, and it's the sine and cosine rule. Okay, so we've got this quadrilateral, and it says we've got to calculate the size of the angle ABD. Where is ABD? ABD. So the object of the question is to work out that angle there that I'm pointing to with the pencil. Okay. Right, that's what we've got to do. So let's have a look and see what we've got. Well, looking at the triangle at the bottom, I've got a pattern there which I recognize as being one of the types of the cosine rule. So whenever you've got two sides, and you know that side, you know that side, and you know the angle in between, you can use the cosine rule to find that side. Okay, so that's one of the instances of the cosine rule. So in order to use the cosine rule here, I'm going to write down that a squared is b squared add c squared minus 2bc cos a. Okay, so therefore this side here, db squared is going to be 10 squared add 8 squared minus 2 times 10 times 8 times cos of 75. Now, it does not matter which side you call b and which side you call c, but it's essential that the side that you call a is the one that's opposite the angle that you've got in between. So that one doesn't matter whether it's b or c. That one doesn't matter whether it's b or c, but this one has to be a, and that's essential. Okay, so we work that out, and that gives us that db squared is 122.58895. So therefore that gives us that db is equal to 11.0720. So now we've worked out that side. So we now turn our attention to the triangle at the top. And in this one, this is an instance of the sine rule. Okay, now the sine rule is all about matching pairs. In other words, when you know everything about one matching pair, you can use that to find something out about another matching pair. Okay, so in this case, we know both the angle and the side. And here we know the side, and we're trying to find this angle. So therefore, we're going to say that sine x over 5 is equal to sine of 135 over 11.075 using the sine rule. And then we times everything by 5 and do the inverse. So we find out when we do that we get the angle x is 18.62. And that is our final answer. Oh no, it says give your answer to one decimal place. So 18.6 is our final answer to one decimal place. So that's how you would do that question. Quite a nice one of its type, I think, that one. Right, this one looks as though it could be quite confusing. We've got stuff going on here. Let's have a look at this one. Right, what's happening with this one? Jeff makes 2 model ice creams, A and B. Model A is made from a solid hemisphere on top of a solid cone as shown below. The radius of the hemisphere is 3.6. The radius of the base of the cone is also 3.6. The height of the cone is 12. Model A and Model B are mathematically similar to each other. Model B is such that the height of Model A to the ratio of the height of Model B is 2 to 3. Work out the volume of Model B. Wow. All right, well, step 1, let's work out the volume of the ice cream cone that Jeff has made, the model. So the volume is going to be, we've got a hemisphere here, which is half of a sphere. So that's going to be like 4/3 pi r cubed, but divided by 2. So that's the same as 2/3 pi r cubed, okay, in order to find the volume of the hemisphere. The volume of a cone is 1/3 pi r squared h. So we've got the formula for that. Now, our hemisphere, we've got a radius of 3.6. So it's 2/3 times pi times 3.6 cubed. So that gives us a volume for that hemisphere there of 97.9161 centimeters cubed. Let's look at the cone, 1/3 pi r squared h. So 1/3 times pi times our radius squared, which is 3.6 squared, times by h, which is 12. So that gives us 162.86 centimeters cubed. So altogether, adding those two results together, the ice cream model has a volume of 260.576 centimeters cubed. Okay, so that's that bit done. Right, now what do they tell us? They tell us some information here about ratios and stuff. What do they tell us? They tell us that A and B are similar, and they tell us that the height of model B is in the ratio of 2 to 3. So between A and B, the heights are in the ratio 2 to 3. Okay, so that is the length there is in the ratio 2 to 3. So the areas is the linear scale factor squared. So the areas are in the scale factors, the ratios 4 to 9. And the volume is the linear scale factor cubed. So the volume is in a scale factor, a ratio rather, of 8 to 27, because it's 2/3 cubed, and 2 cubed is 8 and 3 cubed is 27. Okay. Now what that means is if I want to go from the smaller shape to the bigger shape, if I want to go from A to B, I need to times by 27/8. Okay, so therefore the volume of B is going to be given by the volume of A multiplied by the scale factor, volume scale factor, which is 27/8. And we work that out, and that gives us 879.4, I think it's 94. So, but it says give it to three significant figures, so 879 centimeters cubed, correct to three significant figures. All right, perfect. Right, if anyone has any questions, just type them in the chat, I'll answer them. That's that one. What's next? This is important. I haven't seen this question in a little while. This is, by the way, is a topic called capture recapture. Okay. Somebody's asking, is it for the UK? Yes. GCSE is for the UK. Yes. There is another qualification called IGCSE, which is International GCSE, which is for the whole world. Now, this next one is a topic, something called capture recapture, and I think those of you who are biologists have to come across capture recapture as well. So Polly wants to estimate the number of fish that are in a lake, and on Monday, Polly catches 200 fish. She puts a tag on all the fish and she releases them. Okay, on Tuesday, she comes back and she catches 90 fish, and she finds out that 15 of these fish have got a tag on them. Work out an estimate for the total number of fish that are in the lake. So here's how capture recapture works. Okay, so in the capture sample, Polly tagged 200 fish out of the X fish that are in the lake. Okay, so we've got a ratio there of 200 divided by X, where X is the number of fish in the lake. When Polly comes back and she does a second sample, she captures 90 and she finds out that 15 of them have a tag. Now, the idea in this question is that the proportions are going to be similar, that 15 divided by 90 is going to be the same as 200 divided by X. That's the key idea. So what you do with that is you now multiply 15 times by X, and you do 200 times by 90, and that gives you 15X is 200 times 90. So therefore, X is 200 times 90 divided by 15. So the number of fish in the lake is 1,200. Sometimes they ask you what's been assumed in this case, and I think you would need to assume that the fish are evenly distributed throughout the lake, and that the number of fish that had tags were evenly distributed as well. So that is question 15. Right, question 14, inequalities. Again, a lot of people don't like these inequality questions, so make it a bit smaller. What have we got? We've got to label this region R represented by these three inequalities. So let's think about how we're going to do this. So first of all, we've got X add Y is less than 3. Okay, so all I've done is rearrange that by taking the X across to the other side. So that's the same as Y is less than minus X add 3. And the line minus X add 3 is like that. It's like the line Y equals minus X, but moved up by 3. So it cuts the y-axis at 3 and the x-axis at 3. And we're looking for the region that is below that. So far we've got below that region there. The next inequality is x is greater than 1. So if you imagine you've got a line drawn on, x is 1, and x is greater than 1 is everywhere to the right of that line. So far we've got below that line and to the right of that line. It's got to be greater than y is minus 2. So I've drawn there the line y is minus 2. So we need to be above that one as well. And then finally, it's got to be less than 2x minus 1. And where's our 2x minus 1? Here's my line 2x minus 1. Has a y-intercept of there at minus 1 and a gradient of 2. And we're looking for everywhere that's below that line. Okay, so that's our region there. It is less than all those things there. Now, actually, technically speaking, really, I should have drawn dotted lines here. So imagine that these lines are dotted. Let me just show you what I mean, because we've got strict inequalities. So really, I ought to have drawn dotted lines to represent that we're not actually allowed to have the values that lie on the lines. So it should be with dotted lines. Okay, so dot, 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 dot. This, what I've drawn here with the solid line, would have been if all the inequalities were like that. If they were all less than or equal to, it would have looked like that. But as they're strict inequalities, less than and greater than, we need to draw dotted lines to show that we're not actually allowed to include the values that lie on the lines themselves. Okay, so that's that inequality graphing question done. Oh no, these ratio ones, I don't like these ratio ones. The points A to B to C to D lie in order on a straight line such that those ratios are like that. Okay, let's try and solve this with a little diagram. Here's a diagram that I prepared earlier. Now let's try and think our way through this. So first of all, A to B to B to D is in the ratio 1 to 2. A to B to B to D is in the ratio 1 to 2. Okay, fine, I've drawn that. Then they tell us that A to C to D is in the ratio 7 to 2. Fine, so I've drawn that. So basically that first sketch is just representing the information in terms of ratios on a line. Okay, now what's next? Well, if you've got something in the ratio 1 to 2, that means that this part is 1/3 and this part is 2/3. So instead of writing the ratio 1 to 2, I'm going to say that A to B is 1/3 of the length of that line, because that just makes it easier to work with, okay? And then if you've got a ratio of 7 to 2, that means that this part is 7/9 and this part is 2/9. So I've written it now as 7/9 and 2/9. So that's an improvement. Now, if all of these fractions had the same denominator, that would be even better, because if they all had the same denominator, I'd be able to compare them directly. So what I've done is, instead of thinking of that as 1/3 and that as 2/3, I've multiplied the numerator and denominator by 3. So I've thought of this as 3/9 and I thought of this one as 6/9, okay? Because it's the same fraction, but it just means that now that everything has a denominator, a common denominator of 9, it just makes my life a lot easier. So how does that help me? Well, it helps me a lot because I can see that this distance from here to here is 7/9. This distance from here to here is 3/9. So that means that this distance between B and C has to be 4/9, okay? Because 3/9 add 4/9 has to make 7/9. So now I've answered the question, because everything is, I can say that the ratio of A to B to B to C to D is 3/9 to 4/9 to 2/9. But we wouldn't write it like that. We just times everything by 9 and write it in the ratio 3 to 4 to 2. So I hope that you found that helpful. The key is to represent them all on a line, represent them all as fractions, and get them all with a common denominator. I think that that's the easiest way to approach that kind of question. Right, how are we getting along? Next one. Oh, wow, we've got to a super nice one here. And I think this is the last one that I'm going to do in this particular live stream. Is it the last one I'm going to do, or will I do more? I don't know. I might do more. Might do a little bit more after this one, so we'll see. Okay, so what have we got here? Question 12. Show that x add 2 times by x minus 1 times x add 3 can be written in that form. Now, whenever you've got to expand triple brackets, I personally like to use a grid method to do this, okay? So what I would do in order to do this is I would, first of all, take the two brackets and expand those together. Draw a little grid. So I've got x minus 1 and x add 2, okay? So x times x makes x squared. X times minus 1 makes minus x. 2 times x makes plus 2x. And then plus 2 times minus 1 makes minus 2. So you collect like terms, x squared plus 2x minus 1 is plus x and minus 2. So there's the first two brackets expanded. So we've dealt with that one and that one. Now you write that answer as the top of your next bracket, and the one you haven't used, the x add 3, it goes as the other side, x add 3. And we're just going to repeat the process with this grid again now, okay? So therefore we're going to go x times x squared is x cubed. X times x is x squared. X times minus 2 is minus 2x. 3 times x squared is 3x squared. 3 times x is plus 3x. And plus 3 times minus 2 is minus 6. And then finally, we just collect like terms. So we have x cubed. 3 plus 1 is 4. 3 minus 2 is 1 and minus 6. And that's, I think, the best way to expand a triple bracket. I personally think that using that grid method is quite nice. The only thing you have to be careful with that question is dropping signs, okay? I will do one or two more questions because this one is one that I know that people get wrong for sure. So what's going on with this one? So it says Dan invests £14,000 in a savings account, okay? And the savings account pays compound interest at a rate of 4% interest per year for the first year, and then X for each extra year, X percent. The total amount of £15,297.10 in the savings account at the end of 3 years. Work out the value of X. So Dan originally invests 14,000, okay? So 14,000 goes in, and it gets times by 4%. So that multiplier would be 1.04, okay, to increase something by 4%. It then gets increased by X, which we don't know what X is, percent, for the next 2 years. So we've got to times that by X squared. And at the end of the 3 years, the account has grown. So there is now £15,297.10 in there, okay? So in order to work out what our X is, we need to divide by 14,000 times 1.04 and then square root. So what we're going to say is that X is equal to the square root of £15,297.10 divided by 14,000 times by 1.04. So all I've done there is divide by this. Okay, there it is, divided, and then square root to get rid of the squared. Now let's see what that gives us. Let's get our calculator here. Okay, here's the old calculator and see what we get. So what we're going to do, what's our calculation? It is 15,000. Oh, let's press the fraction. No, let's press the square root button, then the fraction button, and then £15,297.10 divided by 14,000. So 14,000. Oops, one too many zeros there, Mr. Guffick. 14,000 times by 1.04 times by 1.04. Okay, so now when I press equals there, I get that, which is 1.025. Okay, so let's write that down. So X, I've called it X, is 1.025. Now the question, so that is the multiplier, okay? But the question is asking us what the percentage is. So if a multiplier, if you've got a times by 1.025, that corresponds to a percentage of 2.5% is the increase. So the X they're looking for in the question is 2.5. Because remember, if you increase something by 4%, you multiply by 1.04. If you wanted to increase something by 1%, you times by 1.01. So if something gets times by 1.025, that corresponds to a 2.5% increase. Okay, so that is the answer to question 11. 2.5% was the value of X. Question 10, a number n is rounded to 2 decimal places. The result is 7.28. It says using inequalities, write down the error interval. Okay, so 7.28, we're going to say is going to be less than 7.285. You've got to think of the upper bound, but greater than or equal to 7.275. Okay, and that would be the answer for question 10. So think about bounds and think upper and lower bound. Okay, so you basically say we're going to take that that divide, not the way, take that unit, divide it by 2, and add it on to get the upper bound and take it away to get the lower bound. Okay, so that is the 100th column. So you divide it by 2 and you add on 5 to upper bound, take away 5 for the lower bound. But notice that there's a strict inequality there. And that's because if it was actually the 5, we would round up. So we have to have less than there, but greater than or equal to there. And if you don't get that bit right, you will lose a mark on that bit. Okay, next bit. Let's see what's next. Okay, what's Terry doing? Oh gosh, right. So it says that the table gives the information about the money that 51 people spent on meals one day. On the grid, draw a frequency polygon to represent this information. Okay, now a frequency polygon, the most important thing is you've got to use the midpoints, okay, when you're plotting them. That is absolutely essential for a frequency polygon. So we're going to be plotting the midpoints against the frequency. So the first point, where is it going to be? Let's have a look. So the first point is going to be plotted at 2.5 and 2. Okay, so that one there is at 2.5 and 2. The next one is going to be at 7.5 and 5. So 7.5 and 5. The next one is going to be at 12.5 and 15. So it's going to be 12.5 and 15. And the next one's going to be at 17.5 and 12. 17.5 and 12. And then the last one, the next one's going to be 22.5 and 11. So 22.5 and 11. And then the final one is going to be at 27.5 and 6. So like that. So that's how you plot them. Okay, so the midpoints of these classes here versus the frequency, and then you just connect them. And this is important with a straight line. So like with a ruler. I mean, I'm not doing it with a ruler, but they should be connected with straight lines like this. And the other important thing is that notice that it's not connected down there. It's like kind of floating, sort of free floating, as it were, in the axes. So that's how you plot a frequency polygon. Okay, now the next question. Find the class interval that contains the median. So the median is going to be the middle value. So we've got 51 people. So we're going to really want to find out where we've got, like, say, the 26th person. So 51, we divide that by 2. That gives us 25.5. So let's add it up. So we've got 2 in the first class and 5 in the second. So that means we've got 7 at the end of this class here. The next one, we've got 15. So we're at 22 by the time we get to the end of this class here. And remember, we're aiming for 25, and there's 12 in this class here. So it means that the median must lie somewhere in this class. So what we're going to write down is that our median, M, lies in the class where M is less than or equal to 20, but greater than 15. So that's the answer for the class that contains the median. Now, what's Terry saying? Terry says at least one of the people spent £30. Is Terry correct? Give a reason for your answer. So what Terry's thinking is that there's 6 people who are in the class 25 to 30, okay, about how much money they spend on food. Now, the problem is we have no idea how the information is split up in this class. For all we know, all 6 of them might spend £25.10, you know, or all 6 of them might spend £26. So we've got no way of knowing how the information is split up in the class. So what we're going to say is that Terry is incorrect because we don't know how the data is split up in the class, if that makes sense. So that's our answer to question 9. Bit of graph matching next. Okay, what's going on here? Graph matching. So let's have a look. Here are 4 graphs labeled A, B, C, and D. Write down the letter that matches each one. Okay, let's just kind of zoom out a little bit then. Oh, that's good. Right, so this one is going to be y is equal to minus x. Okay, y is equal to minus x. So that one there is going to be, I'll write them down. So graph A is equal to y is equal to minus x. That's the one it matches. B, we've got a quadratic. So that is just going to be B is going to be y equals x squared. C, we've got a horizontal line. So that is going to be like, that could be, C could be y equals 2. That would be fine, which means by a process of elimination that D must be y equals x, which does make sense because that seems to fit the pattern there. Okay, perfect. So what I'm going to do is I think I'll leave it there for those 8 questions. I'll do a walkthrough for questions 1 to 6 in the coming day or two, and put this whole playlist on my website where you've got the walkthroughs. Okay, so the remaining questions for this paper, I'll record the answers to and put them on a walkthrough in a playlist. Okay, I hope that you found that helpful. Now, just as a little incentive, something I'm doing is I'm giving a free trial in any of my year 11 groups. I've got 2 groups at the moment. I've got a target grade 7 group and I've got a target grade 9 group. And I'm going to put a little link in the description of this live stream. Okay. And if you're interested in having like a free trial to see what it'd be like being in one of my small groups, then you'd be very welcome to join us. So I'll put a link in the description. And if you click on that, you just fill your details in there and I'll send you a Zoom link and you'll be able to join us. So I think that'd be great if you could get a real feel for what it feels like in my small groups. Perfect. Well, I hope you found that helpful, everyone. Thank you for staying there all the time, and I'll hopefully see you in a future live stream. Thanks a lot, everyone. See you later. Bye.